Hello and welcome to Electronics Guy. My name is Joao Florentino,
My name is Diego Torres.
and today we'll be talking about the types of diodes, more specifically about the tunnel diode and the Schottky diode. There you have all the links where the information was gotten from for this video. If you want to go check it out.
What is a diode? A diode is a semiconductor device that essentially acts as a anyway switch for current. It allows current to flow easily in a one direction, but severely restricts current from flowing in the opposite direction.
What are they used for? Diodes are also known as rectifiers because they change alternating current, AC, into pulsating direct current, DC. Diodes are rated according to their type, voltage, and current capacity. Diodes have polarity, determined by an anode, positive lead, and cathode, negative lead. Most diodes allow current to flow only when the positive voltage is applied to the anode. A variety of diode configurations are displayed in the graph, as you see in the image on the right. There are a ton of different ways to express a diode.
The first type is the Schottky diode. It is another type of semiconductor diode which can be used in a variety of a wave shaping, switching and rectification application, the same as any other function diode. The right side on image, there is a symbol Schottky diode, and the left is onion metal in the middle junction N type silicon, and there is a specification Schottky diode. Schottky diode curves. When it reaches the negative breakdown voltage, the diode conducts and increase the current negatively and linearly, while in the positive voltage, the current starts to increase at around 0.3 volts and then increase at a much less rate around 0.6 and 0.8 volts, different from normal diodes. When the diode start conducing, the current increment increment is current and not exponential.
Talking about some characteristics of the Schottky diode, for practical silicon junction diodes, the sleeve voltage can be anywhere between zero point 0.6 and zero point 0.9 volts depending upon how it was doped during manufacture, and whether the device is a small signal diode or a much larger rectifying diode. The knee voltage for a standard germanium diode is, however, much lower at approximately zero point 0.3 volts, making it more suited for to a small signal applications. The main advantage is that the forward voltage drop of a Schottky diode is substantially less than the zero point 0.7 volts of the conventional silicon p-n junction diode. Talking about applications, Schottky diodes have many useful applications from rectifying, signal conditioning, and switching through TTL and CMOS logic gates due mainly to their low power and fast switching speeds. TTL Schottky logic gates are identified by the letters LS appearing somewhere in their logic gate circuit code e.g. point 74 LS00.
And the second type diode is the tunnel diode. It is a evenly doped p-n junction diode in which the electric current decreases as the voltage increases. This diode can be used in very fast switching devices in computers, high frequency oscillators, and amplifiers. Tunnel diode curve. The right side is the image tunnel diode curve. Characteristics: a small voltage applied to a tunnel diode. When the voltage is less than the boiling voltage of the depletion layer, no forward current flow through the junction. However, a small number of electrons in the conduction band of the N region will tunnel to the empty states of the valence band in the P region, which will create a small forward bias tunnel current. So tunnel current start flowing with a small application of voltage.
Now, when the voltage applied to a tunnel diode is slightly increased, many free electrons at N side and holes at P side are generated. Because of the increase in voltage, the overlapping of the conduction band and valence band is increased, and the energy level of both sides become equal. As a result, maximum tunnel current flows.
Applied voltage is further increased. The electrons tunnel from the conduction band of N region to the valence band of P region, causing a small current flow, leading to a decrease in tunnel current.
When the applied voltage is largely increased, the tunneling current drops to zero because the conduction band and valence band no longer overlap, causing it to operate as a normal p-n junction diode. The regular forward current starts flowing through the tunnel diode. The part of the curve in which current decreases as the voltage increases is the negative resistance region of the tunnel diode. The negative resistance region is the most important and most widely used characteristic of the tunnel diode. A tunnel diode operating in the negative resistance region can be used, for example, as an amplifier or an oscillator.
Advantage and disadvantage. Advantage: long life, high speed operation, low noise and power consumption. Disadvantage is they cannot be fabricated large numbers. The input and output are not isolated from each other.
Listo. And to end the tunnel diode, we have the applications. It can be used in logic memory storage devices, in relaxation oscillator circuits, in ultra high-speed switch, and FM receivers. Thank you so much for watching. Don't forget to leave a like, comment in the description, and share the video with your friends so they can learn about diodes as well. Bye.